Hello everyone, I am Kanishk and I am going to explain you how to solve any resistance in just 10 minutes. Very important for a class 10 boards as this topic is one of the mandatory topics of electricity and questions come. Okay, I am assuming that you have covered what is resistance, very basic things. You know that this is the symbol of resistance omega and this unit is ohms. This is current 15 ampere, voltage 10 voltage. This is basic things I think you know. We are going to only solve how to solve series and parallel and combination of series and parallel resistance. Now when you will see this, you will get feared how many things are there, right? But it is actually very easy. So before understanding this, let us do a quick revision of series and parallel resistance in just 2 minutes. Series resistance. Formula for it is equivalent R1 plus R2. Now what does it mean? What series means? See, when there are two resistors connected in such a manner that their end points are connected with each other, then we say such resistors are in series. Secondly, when some resistors are connected in such a manner that they are connected in a parallel connection, like this resistor is parallel to this and this is parallel to this. So in this kind we say parallel resistance. We calculate parallel resistance, and series are calculated when they are connected in their endpoints are connected with each other. Here also see it, this resistor is connected with this and their endpoints are connected. So we take them as series. For series, the formula of equivalent resistance, the total resistance is R1 plus R2, and parallel it is actually not R1 plus R2, it is R1 plus R2 plus dash. That dash means how many, the number of resistors which will be there in the circuit, which will be there in series circuit can be added. So like if there are 10 resistors given to you in the question, then you can add all the 10 in series. When the resistors are series, then only add. When they are parallel, the formula is R equivalent R1 plus R2 plus R3. So wait a minute. So when the resistors are connected in parallel connection, the total equivalent resistance between them is calculated by this formula. It is 1 upon R equivalent and this. Okay, you can see it, you know it. Very important thing that students do very wrong. They calculate this value and do not reciprocate. Are see, this value will give you the value of 1 upon R equivalent. But you need R equivalent. So you need to reciprocate the answer that you are getting on RHS. If you will reciprocate it, if you will reciprocate both the sides, then you will get R equivalent to this. Okay, so this is basic formulas. We are not going to go them, and also we are going to solve how we derive this formula. We are going to discuss about that how we derive these formulas in the last. Now see the circuit. Very dangerous circuit, but it isn't. Understand, this is a battery. These are 3 resistors. Current flows through them, flows through the circuit. Current always flows, the conventional current flows from positive terminal of the battery. It goes inside. The current inside the circuit is 15 ampere. Voltage given by the cells or the battery is 10 volt. 3 resistors are there. These are in series. Then these 3 are in parallel. Their magnitudes are given. Okay. One thing. In a series circuit, I, that is current, remains constant. It means that the amount of current that will go from here, positive terminal, will be equal to the current flowing through the whole series circuit. However, when it will reach this point, the circuit becomes parallel. It is no more series. So over here, the current will divide. How it will divide? It will be divided by Ohm's law. You know Ohm's law very well. V equals to IR. So we are going to see it later. Okay, so current divides, and then at this point it merges again, and now the initial value that was here continues to flow back to negative terminal. Basic things. Now let's solve. Now my first question to you is calculate R equivalent. We need to calculate equivalent resistance. Okay, first question is this. Let me raise it. This is a very rough circuit. In the exams you need to draw it properly. Now we need to calculate equivalent resistance. Okay, so let's start from here. Let's make this column. In this we are going to solve this circuit. We need to calculate equivalent resistance. Now see, basically you can easily identify this, that these three resistors are in series, right? I have told you multiple times. So apply the series formula over here. The series formula says that 1 upon not this, R1 plus R2 and so on. So apply here. Series. What are its magnitudes? 7 plus 6 plus 5 ohms. 12, 18, 11, 18, yes. So this is the resistance of these three resistors. I only added them because they were in series. I am repeating this again and again. Now see, now the real part comes. Now you will say that you have calculated this. Here are the parallels, how to do them. We know the parallel formula. So let's do that. Let's apply the parallel formula. I will show you how we connected these two results that we got from here and from here. But first of all, let's apply the parallel formula. It stays, the parallel formula is parallel, I will write this parallel, 1 upon R equivalent, 1 upon R1 plus R2, 1 upon R2 plus 1 upon R3 and so on. This is the formula, right? Let me keep these books aside for a while. Now see, this is basic maths. 1 upon R plus 1 upon 3 plus 1 upon 2 gives you LCM 3, 4, 6. This gives you 13 upon 12 ohms. This is the answer. You are wrong. This is not the answer. See, what was on the LHS? 1 upon R equivalent. Now we need R equivalent. So we need to reciprocate it. I am continuing here. On reciprocating it, we get 12 upon 13 ohms. That is the equivalent resistance of this parallel setup. Okay. Mark this in boxes. Very useful results. Okay. You understood that? You can repeat the video to see how I calculated these all. Okay. Now you will say, sir, we have this, the value of this, we have the value of this, but we need the total resistance of the whole setup. How will we do that? When you got the value of this parallel resistors, the resistance offered by these resistors, you can treat this whole resistance as one. Didn't understand? No worry. See, there were 3 parallel and their value was equal to 12 upon 13 resistance, right? So when we know the equivalent resistor, can't we erase this from the setup? First of all, you need to do in your answer sheet is erase this part. Make a diagram in your answer sheet and erase this parallel part and replace it. You can do it in rough also and in fair also. make it 1 equal to 1 series resistance, and its value was, as we calculated, this 12 upon 13 ohms. Didn't understand? Again I am explaining you again. We had 4 resistances like this. Okay, what we did, we merged them into one equivalent resistance. And what was its value? The total resistance by them, the total resistance offered by these resistors, and we know their formula. So by it we calculated the total resistance and replaced it by a single resistor, and its value was equal to the total resistance. Understood that? Its value was equal to the total resistance offered by them. This is what I was trying to explain to you. Now the question didn't end it. It is very long actually. We got this part 12 upon 13. Now if you will look clearly, you got all these in series. When it comes to in series, you can simply add them. So add all the values, 6 plus 7 plus 5, and you'll get R equivalent. Why? Because look, all are in series now. All are in series now. All are in series now. How it come to series? How they came to series? There were some parallel setups. We merged them into one single resistance, and its value was equal to the equivalent resistance of those parallel combination. Okay, now we know this value, 18 plus 12 upon 13, take LCMs, 13, 12, 180, and 54, so 234 I think. Am I right? Check it. Yes, I am right. 246 upon 30 ohms. This is the resistance, and you will say that it is not an integer value. In board exams it can happen that value might come in fractions or in decimals. Okay, so do not panic over there. So you got the total resistance. How you did? I am explaining again. You converted the parallel setup into series. How you do that? You calculated the parallels equivalent resistance, and that resistance was equal to a single resistance resistor resistance. Okay, so you wrote it value, you erased that parallel setup, and made a single resistor. Its value was this, which came, and then you added all the series setup to get the total resistance. Now let's write the total resistance here, 246 upon 13 ohms. Now erase all this part. Now my next question is, how much voltage is supplied across this resistor? It is a very hard question for you, but it is not. Actually, you know that in series I remains constant. I explained you. Voltage changes. So by Ohm's law, this we need voltage. Now voltage changes at individual resistor point. We have to calculate this part. We have to calculate voltage across the ends of this. How can you do that? You know that I remains constant. I was 15 ampere given in the question. So 15 into resistance, not equivalent. We are asked about voltage across the ends of this particular resistance, and it is equal to 7. So multiply it by 7. You will get 105 volts, unit of voltage. It is voltage around it. Calculate voltage around it. Across it, IR. I is constant. Here, this is the resistance which we are talking. 690 volts. It can be referred as V. Okay, short form. Calculate over here the voltage across it. Simple. 15. I remains constant. We have the resistance here 12 upon 13. Okay, so converting it 150 and 180 upon 13 volt. Okay, it became messy. You can note it. Now we have calculated very important questions from here. Okay, and you need to know that in the series combination I remains constant, and it is a series combination now because we already excluded the parallel one. Okay, now the second thing that can come in your exam is, I think about power. Now we are going to derive series, the formula of series resistance. Series resistance formula derivation, very quick. We are going to solve it. You know that we need to derive this. We need to derive this. We need to derive this. To derive it, let us come back to Ohm's law. V equals to IR. Ohm's law. Here I remains constant because in a setup I is always constant. Okay, so I is constant. Okay, now you know that in a series voltage, the total voltage is equal to the sum of individual voltage. So voltage equals to V1 plus V2 plus V3. It is given in NCERT. That V1 can be referred as IR1 by Ohm's law, IR2, IR3, very easy, I equivalent. Okay, from here I is constant everywhere, so it can be taken as common. R equivalent equal to I and R1 plus R2 plus R3. I will cut, and this is the result we want to prove. Similarly, for this was first series. For parallel, the last topic of today's class or session, derivation of parallel resistance formula. Derivation of parallel, 1 upon R equivalent equal to 1 upon R1 plus R2 plus R3 plus so on. To derive it, come back to that V1. In parallel the voltage remains same but currents add up. Okay, you know that very well, so you can write it here like this: equivalent I plus I2 plus I3. Why I wrote it? Because in parallel setups the current gets add up and the voltage remains same. We can again replace it like this: equivalent. Okay, not this. We can replace this by V upon R. Okay, by Ohm's law. You know Ohm's law already. Equivalent, here it is equivalent. R1, R2, R3. Okay, voltage is constant, so V will be taken as common. Solving here, V will be taken as common. R equivalent V, and here R1 plus R2 plus R3. Okay, V will cut and the formula will become, it will 1 upon R. Okay, let me rewrite it. It become very messy. It was very messy. Let me rewrite it. What we got? We got this. So we will get common. The voltage will get common because it is same. V common, R, and R3 is also there. We will cut, and this equals to this, hence derived. So thank you for this lecture. I hope that you will enjoy it and you know how to solve any question. Thank you.